Welcome to the lab. I'm your host, Trevor Smouter. In this episode, we're on campus at the University of Waterloo in ECE's Student Project Room. This is a great resource for students and is also used for student capstone projects and the ECE298 design course. This facility provides resources to students so that they can assemble and test custom hardware. In several videos, we're going to go through the various procedures used to assemble and verify a custom circuit board. I'm going to start with hand soldering using wire and paste, and then we'll talk about using the hot air reflow and how to solder and inspect fine pitch surface mount components. In later videos, we're going to head over to the manufacturing lab to talk about using preheaters, stenciling, and the reflow oven. This is where it all begins in startup product design. The first thing we're going to talk about is hand soldering with the pencil iron and solder wire, and we're going to start with a discussion about soldering iron tips and the flux that's inside solder wire.
The two main types of soldering iron tips are the chisel tip and the needle tip. The facets on the chisel tip help to hold solder at the very tip of the iron. Surface tension on needle tips causes solder to tend to bead away from the tip. The tips in the lab are all fine point chisel type.
Soldering two metals together is known as a metallurgical reaction. For it to work properly, both metal surfaces need to be clean, and this is where flux comes in.
In the center of solder wire is a rosin flux that's acidic enough to clean the metals being soldered together. The flux runs the entire length of the inside of the solder wire and is deposited at the joint of the metals during the soldering process.
The fact that there's flux in the core of solder implies a special technique must be used when soldering. The approach requires feeding solder into the joint being soldered and avoid the temptation to feed the solder directly into the soldering iron tip. Let's tin some wire to show the proper technique.
Notice here that the solder is initially applied to the interface between the soldering iron tip and the wire. This allows more efficient conduction of heat into the wire being tinned. As the wire heats up, the solder is applied to the wire and not the iron tip. Notice the residual flux bead up on the wire after it is fully tinned. In the spirit of 2-for-1 efficiency, note how easy it is to solder two wires together that have been properly tinned beforehand.
This is a solid approach to soldering that is often used for through-hole components and connectors, as we'll show later. First, let me show you how to do surface mount soldering using solder paste and an iron.
This technique is pretty straightforward. Using a syringe of solder paste, apply a bead of solder to each pad in the component footprint. Once all pads have had solder applied, use tweezers to carefully place the component onto the footprint while ensuring the correct orientation. Next, use the soldering iron to solder each pin. Make sure you heat each pin long enough for the surrounding solder paste to pool up on the pin.
If you have a hot air reflow tool available, then another approach is to solder down the component using hot air, which I'll show you how to do now.
This technique is fast and simple and produces good results for medium pitch surface mount components. First, you apply solder paste to the pads using the same approach shown before. Note how I purposely don't apply solder to one of the pads. I'll show you an approach for reworking this error in a second. Now simply use the hot air tool to heat the chip and board simultaneously. Stop applying heat once it is clear that all the solder paste is reflowed. And that's it. The chip is soldered down. But what about the pin that didn't get properly soldered? We can fix that by applying some solder paste carefully using the tip of an X-Acto knife. With a bit of paste on the knife, spread it on the pin, and then use hot air to reflow the added paste. And that's it, a fast and simple rework after failing inspection.
We've just shown you two approaches to doing surface mount soldering using paste, which is the preferred method. Solder wire is difficult to control when soldering down surface mount components. It is possible, but I'll leave the experimentation up to you as an act of desperation should solder paste not be available. Wire solder is the preferred method to solder through-hole components and connectors, so we'll extend the wire tinning exercise to this application.
Soldering a through-hole component is a 4-step process. Use the iron to apply heat to the pin and pad simultaneously for a couple seconds. Apply solder and let it flow into the joint, taking care to use just the right amount of solder. Continue to heat for another second or two to let the solder flow into the joint, then let the joint cool without moving the component. Some examples of poor solder joints that should be corrected are too much solder, not enough solder, a cold solder joint, and a solder bridge.
I'm going to show you how to use this approach to solder the header connectors on the 8-pin SOIC breakout board we soldered earlier.
Note how I started with 1 pin soldered in each connector. This ensures the connector is held in place while soldering and provides an easy way to adjust the position of the connector if required, simply by reheating the pin while the connector is adjusted. With the connector stabilized, it is pretty simple to make short work of the job just by using the technique shown earlier on the whiteboard.
For finer pitch surface mount components such as the various small outline package, SOP, or SOP, a different approach is required because it's difficult to apply solder to each pad individually. However, there is still a way to do it and get decent results.
Start by applying solder paste across all the pads. Clumps of solder paste are more likely to turn into solder bridges on this type of footprint, so care must be taken to distribute the solder evenly. You can use the end of the syringe to help spread the solder. Careful inspection under a microscope or magnifier while adjusting the solder using an X-Acto blade will help. Clean off any excess solder to help prevent bridges. When you're ready, place the part down onto the footprint and then use the hot air tool to reflow the solder. At this point, careful inspection of the solder job is required to identify and locate any solder bridges. With careful inspection, it was determined that there are solder bridges here, here, and here. I'm going to show you two ways to clear the bridges. The first way is to use solder wick and the iron. Watch how the bridge disappears as the wick is pushed up against the pins. The second way I'm going to show you to clear the solder bridge is using a hot air tool and an X-Acto knife. The procedure is simple. Heat the area of the bridge using the hot air tool, then use the knife to slide between the pins and clear the bridge out. Care must be taken when using this approach so that you don't accidentally knock the heated chip out of place. And that's it. The bridges have been easily fixed.
In this episode, we introduce you to some of the various approaches that can be used to solder together custom hardware. In the next videos of this series, we'll take an in-depth look at the resources available in ECE's manufacturing lab. Remember, practice makes perfect in startup product design.